So our first topic is interfacing LED with our 8051 microcontroller. Wait for a second. For displaying purpose, LED is a main application we are using for displaying purpose. Displaying purposes. For example, we nowadays you can all the see there are many boards they have presented for advertisement. The most of them are based on LED, and nowadays the TVs are also coming with the LEDs. LED is nothing but light emitting diode. This is one of the semiconductor diode. For interfacing purpose, for main reason of using these LEDs for displaying. They are, and one of the human oriented output peripheral are those, and which is mainly used to displaying the result or operands. And one may use other than LED, CRT, cathode ray tube, and LCD liquid crystal displays are also used. And CRT is mainly used for displaying large amount of the data. Cathode ray tube widely used large amount of data. The old TVs, they are using that cathode ray tube technology, but nowadays they are replaced with the LED light emitting diode. And LCD TVs are also in market, but the most popular is one LED because LED is having most applications and advantages comparing to LCD. So in today's lecture, we are going to interface this LED to our 8051 microcontroller. So to connect, there are two terminals in LED. One is a one is a cathode and another one is anode. And we are going to connect. There are two ways of connecting this LED directly to with our microcontroller port. So one LED, for example, here in this figure, what I am doing, the single LED, I am going to connect to port pin. Any port, for example, I am taking port 0. So port 0, I am going to connecting this LED. So there are two ways of connecting this LED to pin, 8051 pin. So how? One method is, first, what I am doing here, directly our anode terminal is connecting. This anode terminal is directly connecting to pin and other terminal is directly connected to ground. This is one method. So what will happen, like this connection, what will happen? See, to connect cathode of LED to ground, what will happen? And in this method, what will happen? 8051, huge amount of current is required for LED. For glowing the LED, the amount is minimum 10 ampere microampere current should be required for glowing this LED. But the 8051 is not capable of sourcing this current. This port, the 8051 is cannot capable to produce this much of current to this LED. It will provide very small amount of current. Due to small amount of current, this LED will not glow with high intensity. It will glow with low intensity, or it's look like a just blinking. Something is blinking inside the LED. So that type of current will be flow for this method connection. The another method connection is there. What will happen here? This is another method. In this method, connect the anode of the LED to the directly VCC here. The positive terminal directly connect to VCC, and the other negative terminal of cathode we are going to connect with port. Here what we are doing here, the negative terminal we are going to connect to ground. Current will flow from 8051 to ground. So this like this current is flowing before in this method. So that's why the 8051 is not sufficient to provide that much amount of current to this LED. So in this method, we are going to connect directly VCC. The voltage we are going to connect to this terminal, and other negative terminal other negative terminal we are going to connect with the port pin. So now the voltage, this is a voltage source, it can provide enough amount of current what required for glowing LED with a high intensity, it is sufficient. So mainly this type of interface is used for many applications. So there are two methods of interfacing LED with the 8051. Now we have seen how to interface LED to port. There are two methods. We have seen these two methods. Now let's see the more information about LED. What happened here? What is the principle of operation of this LED? The principal operation of this LED is very easy. The simple LEDs are also serve as a basic display services. The main principle is the LED is used for display purposes, and it on and off. It on and off. There are two states expressing full information about the devices. And the common available LEDs have minimum commonly available LEDs which operates on 1.7 volt voltage drop, which means which is having which how do we have to apply minimum 1.7 voltage to this diodes. The diode need minimum 10 milliampere current to glow the LED with the full intensity. So if we have connected like this connection, the minimum 10 ampere current should be flow to this LED. Here some of the voltage drop also occur. So what should we have to do? We have to apply minimum 10 milliampere voltage. And the interfacing is one of the most concept in the 8051 microcontroller, because the CPU that can perform some operation on the data given the output. How? How and why we are going to interface these LED to microcontroller? Because one of the important concept of this 8051 microcontroller, the CPU of the microcontroller will going to perform some operation to control these devices what we are going to interfacing to our 8051 microcontroller. And there are many various purposes except the display purpose we are going to interface LED. So the port pins are configured in the output direction. So once the logic 1 is given at the output pin, then the LED will be turned on. Now see, we have connected our 8051 to this. Now what will happen? When the LED will be glow and when the LED will not glow. The LED will glow, then now if now, when I am connected this LED to microcontroller pin, so the port of this pin is now I am using an output port. Now I am using as an output port, which is providing some output function. For that, the LED is going, each which providing some output signal. For that, the LED will be or any device will be operating. So how can I make this LED will be glow? So when the port pin is configured directly to logic high, see, when I am putting 0 here, 0 to make as output port, and when I am providing high signal to this, when high signal will be flow, then this will become 1. When the port of the pin become 1, then LED will be glow. LED will be glow. When the logic 0 is given to LED, when the logic 0, when 0 input is given to this LED, then what will happen? The LED will turn off. Simply think the logic 1. Logic 1, which means 5 volt, will be available to the output pin. Output pin means LED will be glow. When logic 0, that means 0 volt, nothing is giving to LED. So then what will happen? No LED will be glow. So as the LED with a common cathode mode can be connected with 8051 with a resistor here. The LED, the common here, the common cathode. The common cathode is going to use here. And why we are using this resistor? The resistor is using because we are going to connecting directly VCC here. The high voltage will be occur. Due to high voltage, there may be a chance to burn the diode. So that's why to drop the some of the direct voltage, or to avoid the burning of this LED, the resistor is going to connecting. So what we call for this resistor is called as a current limiting resistor, which will limit the current flowing directly to the LED. So this resistor is called as a current limiting resistors. Using this current limiting resistor, we are going to make blink the LED according to 8051 microcontroller. So in this figure, we are going one example how the LED will going to interface, and what this here we are consider one example here. What is example? Write a assembly language program to blink 4 LEDs continuously which are connected to port 0, port 1. Here this is as shown in here. This is a port 1. Here port 1, what we are doing? We are going to connecting 4 LED. From port 1.0 to port 1.3, 4 LEDs are going to connecting. So we have to write a program. The LED should glow continuously. So we have to write program like that. After connecting, it will not operate automatically. We have to give command to this microcontroller. According to that command, it will provide a signal to these LEDs, or it will control these LEDs, operation of these LEDs. So what we do, we have to give a command such like that these LEDs will be glow continuously. Continuously, these LEDs should be glow. So we have to plan accordingly how to write program. So we have to do first accumulator should be what we are task we are going, or what we are program we are going to write here. First we have considered accumulator, because main thing after ALU, accumulator is the main thing. We can use as a data exchange also, data transfer also. So first accumulator is loaded with some value, then it is moved to ports. So accordingly 1 and 0 LEDs will be blink. We have to put some value, either it may be a 1 or 0 in accumulator, and according to accumulator we have sent that information to these ports. We have to send information to these ports. So after that, whatever, if 1 is 0, if 1 will be plus, 1 will be pass, then it will become glow. If 0 pass, it will not glow. So according to that we have to write a program. So we have to start, we have to think from flow chart how we have to write the program. First, start with, we are going to connect these 4 LEDs to port 1. So what we have to do, we have to configure this port 1, these pin as an output pin. First we have to say, first we have to tell the tell the microcontroller, first these pin should be configured as a output pins. These pins should be behave like a output pins. We have to do command first like that. Then after that, what we should do, first in the accumulator, we load with 0. The 0 value should be loaded into the accumulator, and that 0 value move to this P1. How we have to say these pin should be act like output pin? How is nothing but when 0 is enter into these pin, when 0 is enter into these pin acts as an output pin. So automatically it will not enter 0 to this pin. We have to write command like that. So for that, in the accumulator, we have to put 0 signal. Then that 0 signal we have to move to these ports. Then these ports will be dedicated for as the output pins or output port. Then after that, at that time, these are our LEDs will be off. And when zero is occur here, these are off. Then we should call some time delay. After some time, we should load with our accumulator with a high signal. After what we have to do, after some time, we have to load this accumulator with the value n. Then using the accumulator, we have to send the high signal to this port. After high signal to this port will be act as, now it will send a signal here, it will send high signal. Then due to high signal in these diodes, these diodes or these LEDs will going to glow. So we have to wait for some time. Then after we have to proceed same function repeatedly. Our task is, we have to program, we have to write a command like that. This task will be continued automatically. So like that, we have to write a program. Let's see. We are going to writing program now. See the steps, how we are going to writing the programs. First command we have to write like org0. org0 is nothing but from what memory location we are going to writing the command. This means starting our program from what memory location? Starting program at 000H. From here we are going to start writing the program. After reading this, microcontroller will think, oh, I have to start from here. At this memory location, we have to start executing or decoding the instruction. So I am going to write command move a comma hash 0h here. What I am doing here, first I have to write 0h to accumulator at immediate value 0h. I have to transferring or moving or loading into accumulator K. Load the accumulator A with the value 0h. Then what we have to do, move P1 port. We are using P1 port. So now we are moving the value, what the value containing this A, we are moving into P1. Now A is having 00H or 0H, and that value is moving into P1. So now this P1 having low signal. We are going to make P1 as output port and turn off LED. By writing low signal on this port, what will happen? The port will be act as the output port, and simultaneously the LED will be off. LED will remain off. After some time, I want to call some delay. Time delay. I have to wait for some time. So I want to call some delay function. I am going to calling a delay here. Call delay. Just a minute. Wait for a second. After calling delay, now our LED is in turn off position. Now we have to provide some input signal that the LED will be glow. What input signal? High signal. Here there only two language will be there, only 0 and 1, high, low. 1 is nothing but 5 volt, 0 is nothing but 0 volt. So before that we have loaded our port 1 with a low signal. So there is no voltage inside the LED, no voltage flow inside the LED, hence LED remain in turn off position. Now we have to, after some time, we have to make it turn on. How we are going to make turn on? We have to move some value to accumulator. By passing that value, our LED should be glow. 0 F H. What is the meaning of 0 FH? See here. These are our ports. Port position P1.7, P1.8, comma. These are the port like this, like that. Sorry. 6, 5, P1.4, P1.3, P1.2, P1.1, P1.0. These are the 8 pins of the port 1. We are what we are doing here, we are loading A with the 0F value. How 0F value after loading, how our LED will be glow? We are not getting the, see here. We are going to connecting our LED, or we have connected a 4 LED, 1, 2, 3, 4 here. Where we have connected our 4 LEDs? Here. We have connected here. At this pins, we have connected our LED. So, here, these are the 4 pins we have connected LEDs. To make these 4 LEDs to glow, we have to send a high signal. So, high signal is nothing but logic 1. We have to send logic 1. Here we have not connected anything, so we have kept it as 0. So, what is the value of this? This 0, 0, 0 means 0 hex. This is 0. And F is nothing but what? 4F is nothing but value F, hex value. So, what we are going to load in our accumulator, what we are going to load? 0FH. This is nothing but these port 1.0 to port 1.3 should send high signal, because by sending high signal on these LEDs will be glow. So that's why I have loaded accumulator with the 0FH value. I have loaded inside the accumulator. Now from accumulator, move now P1 comma 0, P1 comma A. That A value, what is the value contained, immediate value contains in the accumulator, that will simply move into port 1. Now the LED will glow. Turn on LED. Here LED will be turned on. After that, again I will call delay. Sometime I have to wait. Sometime I have to wait here. So, at what delay we should call? How we know how much delay it will take? For that, we have to write instructions. Should happen after some time, after calling delay, after some time, it should start again. So, we have to write yes, jump to loop. After delay, our instruction should be jump to loop. Loop, there is loop. We have to give loop here. Loop. This is our loop. Here, loop. See here, what will happen? We are going to writing from memory 000. So, what in next step, what we are doing? We are loading our accumulator value to 0H, because we have sent the 0H value using this accumulator to port 1 to make port as output port, and also turn off the LED. So after turn off we have to wait for some time. For waiting purpose, we are calling L call delay. So after some time, after executing instruction, it will wait for certain time and it will start executing next instruction, that is move A, 0FH. So in 0FH is nothing but these four ports will send high signals here. With in accumulator, this value is going into accumulator. I am going to load in accumulator. After loading the same value, we are loading in port 1. After loading this port 1, these four terminal of the pin will become high. So this pin high is nothing but these LED will be turned on. After turn on, what is our main task? We should blink our LEDs continuously. Turn on and off, on and off. We should blink continuously. So we have to make it off once again. So wait for, well, after turn on, wait for some time, then it should turn off. So we don't want to write same instruction again. So what we have to do? We have to jump from starting. Jump from starting to jump. Let's jump to loop. I have sent here loop. So from this instruction, it will start. It will load 0 again, and it will the LED will be turned off and wait some time. And after waiting some time, then it will turn on, and after wait some time and also jump. These operation will be performed continuously. But here one thing we have to see, that L call delay. What is the L call delay and what amount of time should be wait? So we have to write instruction for that delay. So here we are going to write instruction for the delay purpose. Here we have to write delay purpose. This is our loop delay. Whenever it calls a delay, the instruction come here, execute this instruction, and it will move from next instruction. It will move, start executing next instruction. So what is the delay here? Delay is nothing but I am using register 4. At that register 4, I am giving some count. What count? Hash 2, 5, 5. These are the numbers. So I am giving some number to this register, loading the number. What number? 225. I am loading into register 4. Then after that, I am moving R5 with the value to 50. Whenever it called delay, first this instruction will be executed. What will happen? First move the register R4 with this amount. Then after this R4 will become now 255. Then it will come here. Here, what will happen after executing this instruction L call delay? So L call delay, it will come the instruction to delay. here, instruction pointer come here and start executing this instruction. It will happen. What will happen here? It will move R4. It will load the value register R4 with the 255 number. After that, what will happen? Come to this instruction. So what will happen here? What will happen here? Decrement. It will come here. It will come here. So after that, it will come here. After what will it do? It will do. These two are not start because it will this repeat and here still not called. It will come here and it will decrement the decrement and jump non-zero of R4. It will decrement the value of the register R4 register, whatever the value stored in R4, it will decrement particularly. After decrementing, it will jump to repeat. So where is repeat? Repeat is here. First load the value 225 comes into first R5 is filled with the value 255. Then it will come here. It will come here. What is the command? This dj and z is nothing but decrement. Decrement the value. Decrement the value of the R4. What is the value is there? So there are 255 values present in that. So it will decrement by 1. It will decrement by 1. So it will now 254. After decrementing, it will check this value is 0 or not. This is not 0. Then go to repeat. Now it comes to repeat. So in the repeat, what is going here in the repeat? In the repeat, R5 is loading with the value 250 again. Again we are loading the R5 value 250. After 250, it will come to the next instruction. It will come to the next instruction. Next instruction is here. Decrement jump non-zero R5. Now R5 will be checked. So R5, it will decrement value 250 minus 1. So after decrementing, it will check the R5 is 0 or not. Not go here. 0. Then come to this instruction. After that, again it will check until the R4 will become 0. R4 will become 0. Then what will happen here? All the things will become 0. Then after this execution will be going to execute. What is this execution? This instruction is return. Return is nothing but return from this loop. From the delay, we are entered here delay. After delay, we have some spending time here by decrementing the things, loading and decrementing the things. We have at some particular clock pulses, we have wasted time here. We have spent